Lesson 5 on trigonometry is called the sine law. And the sine law is a formula that we're going to use to determine sides and angles of non-right triangles. So a non-right triangle can be a triangle with all angles less than 90 degrees, or it could be a triangle with one angle greater than 90 degrees. And SOHCAHTOA, again, our grade 10 trigonometric identities won't work unless you have a right triangle. So basically the sine law is a nice formula, pretty easy to use, depends on our calculator. And as long as we put the right thing in the right place and do some simple algebra, it's pretty straightforward. So here's an idea that I don't know if we've talked about. We might have talked about it in class, but there's a really nice simple relationship, physical relationship in triangles, and it basically goes like this. The smaller the angle is, the shorter the side opposite is. And the bigger the angle is, the longer the side opposite to it is. And this is one of the reasons why the hypotenuse is always the longest side of a right triangle, because a right angle is the biggest angle in a right triangle. And again, the hypotenuse is the side opposite, so it has to physically be the biggest. So what you see here is the same idea in any given triangle, right or non-right. There's a relationship between the angle and the side opposite. And here are 3 examples of that relationship in the triangles above. And as it says, note that the formula holds for the reciprocals as well. What that means is the reciprocal is the flip, right? So instead of writing sine A on top and little a on the bottom, we can flip it. And this is a valuable relationship to know, because these formulas appear, and this is the one we're going to focus on, because the letters don't matter. But in this example right here, if I want to find an angle, I'm going to use this formula, this form of the sine law. And when I want to find a side, I'm going to use this one. And the reason is the algebra becomes easy, and you're going to see really quickly. So this is going to be a really quick tutorial, other than the number of examples used, and maybe example number 4. But in this one right here, one of the key things you're going to have to ask yourself is, when do I use this thing called the sine law? When you use the sine ratio, you have the opposite and the hypotenuse. And when you use the cosine, you have the adjacent and the hypotenuse, etc. When you use the sine law is when you have a matching pair, when you have a side and the angle opposite. And here's a great example right here. So in this triangle right here, there are 3 pieces of information I don't know. I don't know this side, which would be little z. I don't know this side, which would be little x. And I don't know this angle z. But given that I have a matching pair, the sine law will figure them all out. And in this question, I just want to know x. So given I have the y stuff, I have big Y and I have little y, I'm going to use that part of the relationship, and I'm going to have my letter on top, and I'm going to have my sine stuff on the bottom, and you're going to see in a minute why that's valuable. So again, I'm going to go ahead and I'm going to write y over sine y is equal to x over sine x is equal to z, little z over sine z. Now, I don't know anything about it, so I'm not going to use that part. So the great thing about the sine law is all of these are equal. So the first is equal to the second, the first is equal to the third, and the second part's equal to the third part. So we can pick the ones we want. And this is the one I want. I know my y stuff. I know x, big X, and I only have to know this is what we're looking for. We're looking for this. So we know everything else. And we're going to be able to go ahead and plug in those numbers, and we're going to be able to solve for x. So let's go ahead and do that. So again, it's a good idea to always write the version you want in the order you want, like top, bottom, and then plug in the numbers. So we're going to have y, which is 19.3, over sine of big Y, which is 56, is equal to little x, which I don't know, over sine of 41. And what we're simply going to do is we're going to isolate x. So the way we isolate x is we multiply both sides by the sine of 41. Now again, the sine of 41 is just a number. And if you wanted to change sine 56 and sine 41 into a number, it'll be a nasty decimal, you can go right ahead. But again, I think we can go ahead and multiply both sides by the sine of 41. And I don't know what the sine of 41 is, but they cancel each other out. And here's what we have left over. We have x is equal to 19.3 times the sine of 41 all over the sine of 56. And if you push those buttons in your calculator, you're going to get 15.3. Now, again, you have to ask yourself, does this make sense? Always ask yourself that. And I would say it does make sense because 41 is less than 56. So this angle right here is less than this angle. Therefore, this side, the one we're looking for, has to be less than that side. So let me show you something just on your calculator, what I just did right there. I can enter things exactly as I see it, and the only thing is if your calculator opens up brackets, you close it. We have 19.3 times, you don't have to put times, sine 41, and again my calculator opened the bracket, so I need to close it. And we're going to divide by the sine of 56, and again we're going to close it. And when we hit enter, there's your 15.27, there's your 15.3 as I said. So again, this is done entirely on our calculator, which is a really good thing. We make sure we pick the right formula, we make sure we pick the right part of the formula, we make sure we use the proper version, meaning the sign on top or the sign on the bottom, and then all we have to do is know how to push the buttons on our calculator. So in this example right here, again, what I want you to notice is we have a matching pair, so that automatically picks our sine law, and on my other part, I have the other piece of information. So in this one right here, I have big P, I have little p, and I have little q, and I want to know big Q. So when we set up our ratio, here's what we're going to do. We're going to put our sine stuff on top because that's what I want to solve. So sine P over little p is equal to sine big Q over little q. And again, this is what I want to find out, and I know everything else. So whether you write them down or do a little identification as I'm doing right here, that's really important. It's really hard actually to be wrong now if you pick the right formula. So let's plug in our numbers. The sine of 134 degrees over 6.9 is equal to the sine of Q over 2.5. Now again, before we go on and solve this, hopefully when you look at this angle, 134 is by far the biggest angle of the triangle. So angle Q has to be smaller. And again, the side opposite angle Q is 2.5. The side opposite 134 is 6.9. So and that's another way to make sure we're doing our answer right. So in this one right here, again, we want to isolate Q. So we're going to multiply both sides by 2.5. And when we do that, we get the sine of Q is equal to 2.5, these cancel out, right? 2.5 sine 134 all over 6.9. Now, we want to figure out what this thing equals, because in order to figure out the angle, we have to press that inverse trig button on our calculator. So when you do an intermediate calculation, make sure you take it to 4 decimal places. So let's see what this is. So 2.5 sine 134, again, close your brackets, divided by 6.9. And that's going to equal 0.2606. So as long as we take this to 4 decimal places, we're going to be okay. So the sine of the angle is 0.2606, but in order to find our angle from last day, we know we can push this button right here. And when we go ahead, and again, if you have a decent calculator, I can go second sine to get my inverse sine, and I don't have to push that button. If you look at my calculator, you'll see A and S. My calculator saves the answer. If yours doesn't, you have to punch in that decimal. And I'll just do second answer, and my calculator says 15.1. So I'm going to round that to just 15 degrees. And that should make sense. Again, it has to be smaller than 134, and it is. So everything is good. So here's two basic examples of just using the formula, recognizing that you use the formula. So again, I say a matching pair, an angle and the side opposite. Well, let's look at a couple of wordy problems. And the only difference in these problems is you don't have a triangle. You have to read the story and draw the picture. So you read the story, and I'm going to draw this picture, and you make sure that this picture matches what you think. So here's my picture right here. This left-hand side is supposed to be the tower, and the tower is 56 meters. And as it says in the question, it makes an angle of 86 degrees with the ground. And the student is way over, little Johnny is way over here. And he looks at the top with his clinometer, and he measures it, the angle of elevation. Elevate means, elevators go up, look up. So our angle of elevation is 37, and the question is asking, well, how far away is little Johnny away from the leaning tower? So again, it's very important that you can draw a picture. So in this one right here, we do have a matching pair, but I don't have one of the pieces of information I need to know. In order to know little x, I'm going to call this big X. I need to know that angle. So again, we need to know angle X. And the nice thing is we have two angles of a triangle, so we can figure out what angle X is. And angle X is equal to 56 degrees. So given that I know angle F is 56 degrees, I have my matching set and one of the other piece of information. So in order to do this one, if I'll call this side Y. So in order to do this, I want to know little x, so I want to use this formula. Little x over sine x is equal to little y over sine y. So again, I want to do that because whatever my unknown is, I want it on the top, because then I just multiply over the bottom. And we're going to go ahead and plug in our numbers. X sine 56 is equal to 56 sine 37. So there's this idea right here, and we're going to multiply both sides by the sine of 56, because anything divided by itself except 0 equals 1, and we get x is equal to 56 times the sine of 56 divided by the sine of 37, and we're going to plug that into our calculator. 56 sine 56 divided by the sine of 37. And we're going to get 77.1. So that's equal to 77.1 meters. And that should make sense, because this angle here is bigger than this angle here. Therefore, this side should be bigger than that side. Okay, one last one. So this is really on Vancouver Island, and I Googled the distance from the direct distance from Ross Bay to Oak Bay, and I think my answer is right. So the first thing we need to do is to understand the compass direction. And here's how we read this. The first letter is the start. And the second letter tells you how many, or the second part, the number tells you how many degrees to go, and the last one tells you which way. So it's like a compass rose. Here's north, south, east, and west. And here's what north 57 east says. If I start north, I go 57 degrees to the east. And that would be the direction of travel. So this is, always start with the first letter, go numerically the number of degrees to the direction. So if it were 57 north, 57 west, that arrow would be on the other side and it would be pointing towards the west. So in this example right here, here's what this says. Oak Bay is in a direction north 57 east from Ross Bay. So we want to draw our compass. So here's Ross Bay. And what this says is Oak Bay is north 57. So again, there's our 57 degrees right there from Oak Bay. Now, if we're traveling in the water, the boat can't travel across the road. So what the boat does is it travels on a north 79 degrees east from Oak Bay, and it goes 1.9 kilometers, and then it turns and travels to Oak Bay. So I'm going to do this one in red. So here's what the boat's actually doing. There's the land direction. Here's how the boat's going to get there. It's going to go 79 north 79 degrees east. So we're going to start at the north, and we're going to rotate 79 degrees towards the east. And here's what the boat will be doing. It will be going on this pathway. And again, that pathway is 79 degrees, and it gets 1.9 kilometers. And then it turns, whatever, and it goes another 1.1 kilometers, and that's where it goes. And I'm going to call this, I'm going to label Ross Bay S for start, and I'm going to label Oak Bay F for finish, and I'm going to label the point it turns M for middle. And here's what we want to know. We want to know little m. How far is little m? So you're looking at this triangle and you're going, oh my goodness, I don't know any piece of information. But in fact, you do know this one right here, because this one, we'll call it angle S. Angle S is equal to 79 minus 57. So we have those two compass ideas, and here's what we have. So angle S is equal to 22 degrees. So given it's equal to 22 degrees, here's what I now have. I now have a matching pair. I have an angle in the side opposite it. Now, what I want to find out is, I want to find M. So again, here's the idea. I want to find little m, but before I can find little m, I need its matching angle. So I have to find big M. And I can't find big M as it is, but what I can do is I can find angle F because I know little f. So we're going to have to use the sine rule, sine law twice. So again, this is a tricky problem, but it's the logic it's working your way through. So let's find big F, the angle. If we know big F, we can find M, big M, angle M, and away we go. So again, I'm just going to plug them in. Given that we want to find F, I'm going to use my sine information on top, and I get this. And I'm going to trust that you can use the calculator, or if you want to go back later and look at this, you can push the buttons, but I'm going to go really quickly. So I'm going to multiply both sides by 1.9. And I'm going to figure out what that is. And when I push that into my calculator, I get 0.6470. And when I take the inverse sine of 0.6470, I get 40.3. So angle F is 40.3 degrees. And again, when you're doing your intermediate calculations, if you round too early, your answer is going to be off a little bit. So if you wanted to say 40, that would be okay. And that's what I'm going to do. So therefore, angle M is going to be, angle M is going to equal 118 degrees. So again, if we know 22 and 40, that's 62, and 180 minus 62 is 118. So there we go. We have angle M now. It's 118, and there we have one piece of information about our matching pair. So now, when I do my actual calculation that I want to figure out little m, so I'm going to use this formula where the unknown is on the top, and I'm always going to go back to my information that I was given. And again, I'm going to multiply both sides by the sine of 118 degrees. And this is entirely done on our calculator. And when I push that into my calculator pushes out 2.6 kilometers. So in summarizing the sine law, you have to know when to use it. And the giveaway is a matching pair. So an angle and the side opposite. And then as soon as you know to use the sine law, then which version do you use? Do you use the sign on top or the little letter on top? And that all depends on what you want to find.